options, picture. All right, so video 1 of 4, where eventually you'll see all of the reviews. So what we're about to do now is the first period video. It'll have 1, 5, 9, 13, 17, etc., etc. You got to use your math to figure out which problems are in this video. Number 1. Yeah, this starts out easy, but that's okay. State the domain and range of each function. Of each relation. I don't know that I really need to state the domain and range because it tells you. Although, you know what? I do. I want to, because that domain is a discrete list of numbers. So the domain is not 100 to 300. It's only 100, 200, 300. So there's a difference between listing the values in a domain and like listing them all out and then giving an interval. Like number 4, you'd have to give an interval for domain and range. But number 1 and 2 and 3, you would just list the values for domain and range. Then determine whether each relation is a function. This one is a function. Yes, function. Is it 1-to-1? Mm-hmm. Yes, and you can see why it's called that, because not only does 1x go to 1y, but 1y goes with 1x. Yes, function, and yes, 1-to-1. Number 5. Graph each relation or equation and determine domain and range. Determine whether it's a function, and if it's 1-to-1. Then state whether it's discrete or continuous. Let's see. 2, -3, 2, 4. Uh-oh, I've already got a problem already. I've got big problems here. So definitely not a function. I guess I'm going out of order. I'm supposed to do domain and range. But that does not pass the vertical line test, right? Like, not at all. Or you can say, look, I've got 2 going to -3, and 2 going to 4, and 2 going to -1. Like, this would be the greatest vending machine, right? You hit the 2 button and you get 3 things. Fabulous. But not a function. If it's not a function, the 1-to-1 question is irrelevant. It doesn't matter. So you can just ignore that. Determine the domain and range. Domain would be the x values. So that would be 2, because that's the only x value. Range would be the y values. -3, 4, and -1. And that is discrete because it's a set of points, not a infinite number of points. I guess be careful with that, because even number 4, that's not discrete. There's an infinite number of points on that circle. It doesn't go to infinity anywhere, but there's still an infinite number of points on that circle. Number 9, f of 0. Well, that's pretty easy. Look at the f function, plug in 0, and we get -1. Well, that was nice. I like problems like that. Nice to have a few of those on the test. G of -1. Just make sure you're looking at the right function. So we'll look at G, and we'll plug in -1. Square -1, we get 1. And then 2 minus 1 is 1. Yippee. Yeah, we want ones like that on the test. And yeah, there's a few like that, but 17. Oh, good old 17. Will that be on the test? I mean, the easy answer is to just say maybe. There's some tricky ones on the test, but it's not all tricky ones. It's only a few tricky ones. Right? You guys are all smart, and if we made them all easy, then everybody make 100. You'd be okay with that, but we don't want that. We want to separate the men from the boys, the women from the girls, however you want to phrase that. So yes, there are a few that are challenging. 17. Find all of that. This is going to be a multi-step deal here, so I'm going to need to find f of a plus h first. I'm going to find all the pieces first, and then we'll worry about putting it together, because there's no way to just jump straight into an answer here. So f of a plus h means in place of x goes a plus h. Clean that up, and then we'll put it to the side and move on to the next thing. A squared plus 2ah plus h squared plus a plus h. Right? Right, we know how to FOIL. Right, I don't need to write it all out, or do I? A plus h times a plus h. Got it? The middle two terms make that 2ah. Alright, that's about as, there's nothing more I can simplify, so that's as good as it gets for f of a plus h. F of a, that'll be a little easier, just plug in a. So a squared plus a, that's easy. And now I need to plug in both of those pieces into this thing that I'm supposed to find. So let's see if we can try to color code this or something to show what I'm doing here. So f of a plus h is all of this yellow stuff. There's my f of a plus h. And then I need to do minus f of a. Let's be careful with the minus sign. I need to subtract all of that. So either distribute it right away or hold off, but just make sure that negative ends up on the a as well. All over h. What a mess. Oh, but some nice things start happening here. What can I cancel? Tell me one thing I can cancel.
A squared.
A squared will go away, for sure. Anything else?
Plus a.
Yes. Yeah, careful. The plus a's. Normally we shouldn't be canceling two plus a's, but that's not really a plus a, right? That one's a minus a. So it'll cancel with the plus a. Some ambitious people will keep canceling. I'm going to rewrite what I've got. And then realize, oh, this is good news. They all have an h in them. So I can cancel that h out. If you prefer, it might be easier to factor the h out. That's a little more like formal, official looking to do it that way. You don't have to. Oh, there we go. There's my answer. The reason this is in here, that's not some random thing. That's called the difference quotient. We use it in calculus a ton. We do more with it. That's the algebra part of the calculus problem. So we like to start you early, making sure you can handle that algebra, because in calculus, that's as long as that problem was, that was a little piece of a bigger problem. How's that for encouraging? I'll see you in a couple years in calculus. Or I won't, because you'll be in calculus BC with Miss Murray. I haven't done BC in a while. I can do it, just hasn't been a while. 21. Okay. Oh, kind of a brain shift here. Now we're not away from, I mean, we're still doing algebra, but not the algebra review stuff, but the parent function stuff. So I know that's an absolute value, so I know it's a v, but there's been some changes to it. And this one's one of the tricky ones, so we jump straight to a tricky one here. What do I mean? What do I need to do first before I start? Yeah, factor out the 2. Because maybe it looks like it's going right too, but I got to factor out the 2. That leaves x minus 1. And now everyone's probably good with that. Let's see. Up 3, right 1, vertical stretch. I didn't even say to write them out, but there's problems that do say to write them out, and it's helpful because that's what I'll use to graph it. Graph it, give the domain and range. So up 3, right 1 puts me right there. And then a vertical stretch. So up 2 over 1, the sort of slope. It's not really slope, but kind of. And again, take the quick second to make sure you graphed what you said you were going to graph. I think I've said it before, but the mistakes are almost always not from getting to the equation to the description, but from the description to the graph. So up 3, over 1, vertical stretch, yes, I feel good about that. Domain, left to right, is all real numbers, negative infinity to infinity. Range is bottom to top, so the first value happens at 3 and goes to infinity. Alright, these are pretty quick, pretty easy. Describe the transformation of the parent function. So you tell me what's number 1. Left 6. Number 5. Right 9. Up 10. Number 9 looks strange, maybe.
No, that's a horizontal stretch by 7.
Okay, up 2 is the easy part. And a horizontal stretch by 7, the way it's written. Now, sometimes you can do, like if you don't like the horizontal thing, this one you could factor out the 1/7. It's not really even factoring, you're just moving it out. And that makes it look like a vertical compression of 1/7. Yeah, you can't always do that, though. You can't always slide that 1/7 in and out, right? Like if it was squared, you couldn't take a 1/7 outside of that. That would have to be a horizontal stretch by 7, or a vertical compression by 1/49. So you sort of could take it out, but it'd have to be a 1/49, which would be a terrible graph to have to graph, right? You'd have a parabola that was like really squished. Probably more squished than that. But I could argue that my scale, I didn't put my scale on there, so my graph is accurate, if you trust my invisible scale. 13. Kind of a backwards problem. I don't know that we've done one of these. So you do 13 real quick if you haven't already. So square root, vertical stretch by 6, vertical stretch by 6, down 1, that would be a funny answer if somebody put that. Six square root of x minus 1 at the end to get the down 1 part. Yeah, that's right. Okay, so that was only 13 minutes. That concludes the first video of the day. If you're looking for other problems, go look for the other videos.